Today's review opener is a review over everything from Unit 5, which includes sections 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, and 4.8. So we're going to go over each one of these questions before you take the test. Today is 11/20. And question 1 is asking to write the equation for the permutation, 10 permute 3. And so you can recall from your 4.8 notes, we have combinations and permutations, and the formula for permutation is MPR. So M exclamation point, or M factorial over M minus R factorial. So we've got our M, we've got our R, so that's going to be 10 factorial over 10 minus 3, or 7 factorial. Number 2, given the NTHS has 18 students and 5 positions for the officers, how many ways could the officers be selected? Since each officer position is unique, order matters. That's the key. So we have to decide, it says write the notation, the equation, and then the solution. So if order matters, is it a combination or permutation? The answer is it's a permutation. So the notation for that is 18 students permute 5. And then it says write the equation, so similar to the previous, it's going to be 18 factorial over 18 minus 5, which is 13 factorial. And then the calculator, we have a button under your math menu. Over to the probability menu, NPR, and for some calculators you have to enter the 18 before you hit the probability menu under math menu. So I'm going to type in my 18 and my 5, and we get 102,000, 1,028,160. So quite a few ways. Next, we have write the notation and definition for conditional probability. So the 4, 5, 4, 6 notes. So those are the notes that you took in class on your flex day. Let me grab a copy of those. So you can see conditional probability is the first definition there, so you need to just write that in. The probability of event B, that event B occurs given that event A occurs. So the probability that event B occurs given that event A occurs is called conditional probability. And then it's denoted, the notation for that is P, parentheses, B, then this straight line, A. And we know that we read the line when we come to that part, given that. Probability of B given that A occurs. So that's what we have in writing, and that's what we have in notation, and that's the answer to number 3. Number 4, list all possible outcomes for tossing a coin 4 times. So that would be where you just list out each one. You could also do the tree diagram for this type of problem. So you've got heads on the first round, And then on the second round, you could have heads or tails. And then the next round, we could have heads or tails, heads or tails. And then, so we're on round 1, 2, 3, and then 4, heads or tails, heads or tails, heads or tails, heads or tails. So the first option would be heads, heads, heads. The second option would be heads, heads, heads. Sorry, there were 4 heads. 3 heads and a tails. And then 2 heads, a tails, and then a heads. Heads, heads, tails, tails. And then let's make these all even. Heads, tails, heads, heads. Then heads, tails, heads, tails, heads, tails, heads, tails, heads, tails, tails, tails. And then we could do the same thing with tails. So we can have tails with heads or tails. We could have heads or tails, heads or tails, heads or tails, heads or tails, and so on. So now we have tails, heads, 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 tails, heads, heads, tails, tails, heads, tails, heads, tails, heads, tails, 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 heads, heads, and tails, tails, heads, tails, 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 heads, and all tails. So we've got 4, 8, 12, 16 options. You could do that same process with fewer tosses or more tosses of the coin, just by making the 2 different tree diagrams, one with the heads and one with the tails. So we'll just say C backside. Number 5, a magician has a hat filled with scarves of a variety of colors. So we have 10 pink, 12 turquoise, and 8 magenta. If the magician randomly pulls a scarf from his hat and then puts the scarf aside and randomly pulls another scarf from the hat, what is the probability the magician will pull 2 pink scarves? So we first need to know the total number of scarves. So that would be 12 and 8 is 20, plus 10 is 30. So the first time magician pulls a scarf from a hat, there's a 10 out of 30 chance that that would be pink. And then we're going to multiply that, these are independent events, by the probability of pulling out a pink scarf, given that he just pulled out a pink scarf and set it aside, meaning there would be 9 pink scarves left out of 29. So we could enter that in the calculator as is. You could do 10 out of 30 or 1/3. We know we can reduce that, times 9 out of 29, and we could get rounded to 3 decimal places, 0.103. Probability of pulling out 2 pink scarves, having set one aside. Number 6, the lottery ball game. In the lottery ball game, there are 15 numbered balls, 1 to 15. Lila, the lotto lady, chooses a ball at random, replaces it, and chooses another ball at random. What is the probability that Mary, Lila, removes balls numbered less than 4? So that would be, balls less than 4 would be 1, 2, and 3. That means there are 3 balls less than 4 And so probability of pulling a ball less than 4 would be 3 out of 15, given that there are a total of 15 numbered balls. Times the ball is replaced, and so we have the same probability the second time. We could simplify this 1/5 times 1/5, which would be 1/25, or enter it in your calculator. If you didn't recognize, to reduce that, you could just type it in as is, 3 out of 15 times 3 out of 15. You could get a decimal answer, or always you can convert that into a fraction hitting the math menu, enter and enter again, and you get 1 out of 25. So depending on how the options are given, you may need to be able to give a fraction, reduced, or a decimal. Number 7, 8 vocalists and 12 instrumentalist students were planning a Friendsgiving celebration. If 25% of the vocalists and 75% of the instrumentalists actually go, find the probability that a random student who goes to the Friendsgiving is a vocalist. So there's a few steps to this one. 8 vocalists and 12 instrumentalists, 25% of the vocalists. What is 25% of 8? So that would be 0.25 times 8. So that's 0.25 is the same as 1/4. 1/4 of 8 is 2. So we know that there are 2 vocalists. Again, you could just type that in your calculator as well. 2 vocalists are going. 75% of the instrumentalists are going. 0.75 times 12. That's 3/4 of 12. So think about 12, 3/4 times 12 over 1, reduce. That's 9. So 9 instrumentalists. Again, calculator works just as well. So let's look at the next part. So we took 75%, did that part. Now is find the probability. Probability that a random student who goes to the Friendsgiving is a vocalist. So this is basic probability. Vocalists, there are 2 out of a total 11. So we could write that as 2 11ths, or we could write that as a decimal, which is 0.181818, or we could just round that to approximately 0.18. And that is your opener.